Welcome you all for the subjects of the measurements and instrumentations. The course objective of this subject is to acquire the knowledge on measurements and instrumentation systems, to understand the workings of various electrical and electronics instruments, storage and display devices, to apply the concepts of instrumentation in sensors and transducers. So these are the subjects syllabuses: instrument and measurement systems, electrical and electronic instruments, comparative methods of instruments, storage and display devices, sensors and transducers. So here some of the textbooks I have shown for you. You can use these books, it will be useful for us. Like A.K. Shawnee, he is a well-known renowned author, electrical and electronic measurement instrumentation. And you can see Albert Williams and sensor transducer frame. And I'm going to the subjects of a course outcomes. You're having 5 course outcomes in the subjects. CO1 explains the functional elements and types of instruments. Today we are going to see about the functional elements and types of instruments, and it will summarize the concepts of electrical and electronic instruments, which will CO3 applies various comparative methods to measure the electrical parameters. CO4 will illustrate the construction and working principles of various storage and display devices. CO5, which will infer the concepts of sensors and transducers for various applications. These are the 5 course outcomes which comes for the measurement instrumentation subject for you. And the unit 1, you will find the functional elements of instrument, which we will go and see in the functional elements, and the static characteristics, dynamic characteristics, error in measurements, calibration methodology, construction and working principles of moving coil, and constructions and working principles of moving iron instruments. So in this topic I will cover the functional elements and static characteristics of measurements. This will be covered in this presentation. So measurement, what is the measurements? It is the action of determining the size of amount or degree of something by using a device marked in a standard units. We all know that some component will be we are buying on the shops or any other places, we will get with respect to of quantity. It may be different by 1 kg or 2 kg, or I need some amount of things. Like example, you can take a temperature, you will mention the degrees with respect to 35 degree, or in the purchase of things of a kg. That's why they are saying measurement is the action of determining the size, what amount of size and degree of something by using the device marked in standard units. And what is the instrument? The device that is used to measure quantity in terms of another quantity is called an instrument. The device used for measuring the things is called an instrument. The quantity under measurement is called measurand. What are the things you are going to measure? That particular thing is noted as the measurand. That is, they are saying as the quality under measurement is called a measurand. For example, unit is a quantity which is used as a standard reference systems. We will use a standard reference system of notation. There is the example of a SI system, we can say. And the major problem of it is any measuring instrument will certainly have a errors there. So hence it is necessary to select the appropriate measuring instrument and measurement procedure, which minimizes the errors will occur. So error is defined as nothing but it's the difference between the actual value and measured value of the instrument. Error is defined as difference between actual value and measured value. It is the instrument. And calibration, it is the process of making an adjustment or marking a scale so that the reading of instrument agree with the accepted certified standards. That is why we have to make a measurement. We need a quality verification by monitoring physical quantities, quality control by controlling the measurement process, quality analysis purpose by validating theoretical models and building the empirical models. These are the 3 things is necessary for the measurement of which will avoid the errors. So that's the qualification, verification, quality control and analysis purposes. These 3 things are noted. Here's some of the examples. If you're going for the parameters, the instrument is there. Measurement is the parameters of its temperature. You will use the instrument as a thermometer. So manometer is the pressure, and if you're going for a heat energy, using calorimeter is used. This is the functional elements of instrument, which it is measuring medium required. If you are going to measure something, we need a certain medium is there, and primary sensing devices, and variable conversion element, and variable manipulation element, and data transmission element, and data storage, and finally we will have a data presentation element, which will show to the observer That is the final thing. Initial of a function element, you need a measuring medium, what you are going to measure, and the primary sensing metal and variable conversion element. That is from whether it may be on any kind of metal, it has to be converted to some part of it. And finally, variable manipulation and data transmission. And data transmission should be stored in some is data storage and data presentation, and finally it is the observer. So these things is the first element is the measuring medium, and some examples it is you can take thermocouple and strain gauge. If it is a thermocouple, you need to measure the temperature devices, and in case of it is a mercury glass thermometer, the output reading is given will be by the mercury will shows the reading. That is the particular primary sensor is also the complete measurement system in itself. So here it is a mercury thermometer, I have shown it. It will have a mercury will be present in this one. If it is increases, when it will increases, if the temperature is get increases, the liquid medium of it mercury will get increases. That's the thing. You can measure using the scale of that. And some of the measuring system in the computer sensor transfer signal conditioning systems, data acquisition and data processing and data transmission. This is the method in the computer systems. And some of the standards is there. Standards are classified as national standards, international, and de facto and industry standards. These are the types of classification of the standards. And characteristics of measurement systems. The characteristics are classified into the two types: static characteristics and dynamic characteristics. Static characteristics is the performance criteria for the measurement of quantities that remain constant. It will remain constant for certain duration. That is the static characteristics. Dynamic characteristics, in the name itself it will say the dynamic. The relationship between the system input or output when the measured quantity is varying rapidly. That is they are mentioned as the dynamic characteristics. And the static. The static means the input to the instrument is either kept constant. That is static. We will know static that remains the same of it is the static. It is given by the terms of range span. Range, it is the maximum and minimum values of the input or output which the instrument is supposed to work, and the span is difference between the maximum and minimum values. It is the span. Example, temperature transducer with a range of 10 to 500 degrees Celsius. It has a span of 490. That is the span of the static instrument, static characteristics. And accuracy, it is the closeness of the measured value to the true value. Accuracy is the closeness of the measured value to the true value is called the accuracy. You will know that if it is a striking on some point, it should be accuracy should be greater. Good. Example, you can say the voltmeter with the rating of accuracy, it is a plus or minus 10. What it is mean? Percentage. The values may be increases or decreases of 10%. Example, if you are saying the 5 volt, it may be variation of a 0.5 plus or minus 0.5. And precision is the closeness of measured values among themselves, but they may be far from the true value. So yeah, precision instrument need not always be accurate, but accurate instrument will always be precise. So here some of the graph I have shown for accuracy versus precision. See 3 plots of a target. So first one you can see it is the high accuracy and high precision, because all the points are in the particular target is the here target is the red point is the target. So all targeted on high one. So accuracy it will near to that, and high precision is it is all the targeters near to that accuracy point. In second one you can see it is not shooted on the particular red target, it shooted on near to the green one. So there is accuracy is lesser, but the precision is the high precision, because the points are all the points are very near to the closeness values are very near. That's the high precision. Third one is low accuracy and low precision. That is the points is not even, it is all scattered. That's the difference of accuracy and precision. And linearity and sensitivity, it means the output reading, and sensitivity is the ratio of the incremental output to the incremental input. It will varies with respect to if it is with respect to the input and output. Sensitive, which is maybe depends on the conditions. If the temperature maybe increases and the pressures and humidity etc. will increases, that is the named as a sensitivity. And zero drift and sensitivity drift. In this graph you can see in the zero drift and sensitivity drift is there. Zero drift, it is characters of zero drift if the scale is reading is getting increased by bias, which describes the effect with the zero reading of an instrument is modified by change in ambient condition. Here you can see if it is a 0, even though if there is a change in the ambient conditions, if the temperature increases, the device may get disturbed by effect. And sensitivity drift also is defined as the amount of which an instrument sensitivity of measurement varies as the ambient condition also changes. That's a zero drift. And repeatability and reproducibility is the repeatability describes the closeness of output readings when the same input is applied repetitively over a short period of time with the same measurement conditions. And reproducibility is describes the closeness of output reading for the same input when there are changes in the method. Hysteresis if the input measured quantity to the instrument is increased steadily from a negative values. The output reading varies in the manner shown in curve A. If the input value variable is then decreased steadily, the output values may be in the increased manner that have been shown in this graph. So thanks for watching this video. Thank you.